when we know that triangles are similar, we can figure out missing side lengths, and we can also figure out the scale factor between the two of them. Now, we said that similar triangles are proportional, which means that we can set up fractions to compare their sides. Now, I usually like to put the small triangle side lengths on top and the big ones on the bottom. Doesn't matter which way you do it, okay? So we know these two side lengths correspond to each other, so we can write 5 over 10 here. Now we have some variables here, but we can solve for them, okay? Now looking at this side here, we know this 9 corresponds to the x. The 9s are small triangle side length. I'm gonna put that on top. The x goes on the bottom. And then for the last one, now we have our y on top. That's our small triangle side length over 20. So we can just ignore one of these fractions and we can cross multiply here to figure out what our x should be. Now this one's pretty simple. You might be able to do it in your head. All right, we have 90 is equal to 5x. And if we were to divide by 5 here, we would get that our x is 18, which would be this missing side length right here. Now you might already be able to tell me what the scale factor is between these two triangles, which is awesome. But then we're gonna do the same thing again, right? We can say, I'm just gonna move this over here, cross multiply, got the y and the 10, and the 5 and the 20. So we got 10y equals 100. So when you divide by 10, you get that y is equal to 10. Now we know that all the sides are proportional, and we just showed it. The scale factor between these two triangles is going to be what you could multiply these side lengths by to get to this triangle, or vice versa, divide these side lengths by to get to that triangle. So in this case, our scale factor is going to be 2. Donkey Kong out.